All right, here's your last teaching video of the year, of this year of a second COVID lockdown, 2021. So example 16, page 419. Solve for x. So number A is 2 times 3 to the power of x equals 5 times 2 to the power of x. So I'm going to start by logging both sides of the equation. Okay, now using law number 1, we can separate this out into 2 logs on each side. So log 2 plus log 3 to the power of x equals log 5 plus log 2 to the power of x. Okay, now using law number 3, we can bring that x down as a coefficient of each of those logs. Log 2 plus x log 3 equals log 5 plus x log 2. Okay, we're trying to isolate x to solve for x. So let's put everything with an x in it on the same side of the equation. So we'll keep x log 3 here. We'll subtract x log 2 from both sides of the equation. Whoops, got the x. We'll keep log 5 on the right hand side, and we'll subtract log 2 from both sides of the equation. Okay, now we can factor out an x. Log 3 subtract log 2. Now if we wanted to, we could combine these logs together using law number 2. I'll just do that to sort of simplify things. That's log 3 over 2 equals times x equals log 5 over 2. And now to get x by itself, divide both sides by log 3 over 2. Now, important thing, sometimes students get mixed up thinking, or they think incorrectly that we can cancel those logs out. We cannot. This is a number, the logarithm of 5 over 2. Okay, it's not an operation, it's a number, logarithm of 5 over 2. This is a number, logarithm 3 over 2. So we can't separate that out from each other. Okay, all right, so we plug this in a calculator. You could have also, back at this step here, just divide both sides by log 3, subtract log 2 to have that under here, and then poke it in your calculator. Either way would be fine. All right, so log 5 divided by 2 divided by log 3 divided by 2. And we get 2.26 rounded to 3 significant digits. X is approximately equal to 2.26. 2.26. Okay. Number B. Now, the really interesting thing about number B is we're going to be able to factor this guy. Okay. So if we think of changing e to the power of 2x to e to the power of x squared, that's actually equal to e to the power of 2x, okay? Because this would be power of a power. We would multiply those exponents together to get 2x. I'm just going to write it this way so we can see that if we let, and you can actually put this in part of your solution if you wish to, you could let e to the power of x equal a. Okay, I'll choose a instead of x because x might get mixed up with e to the power of x. So let's replace all the e to the power of x with a. So that would give us a squared minus 3a plus 2 is equal to 0. Okay, well, all of you know how to factor this guy already. That's a regular trinomial. It's going to factor into 2 brackets A and A as the first term of each bracket. We need these numbers to be two numbers that add to -3 multiplied to 2. So that would be -2 and -1. So let's double check. If I expand this bracket, A squared minus A minus 2A, which is minus 3A, and plus 2. Okay, good. Now we need to change it back because our question wasn't just this simple guy. It was this one with e to the power of x in it. So if you choose to do this in your solution, you can change it back now. Let a equal e to the power of x. Okay, so therefore e to the power of x subtract 2 and e to the power of x subtract 1 is equal to 0. All right, now if you are comfortable factoring from here down to here by just thinking about my variable is e to the power of x instead of a, and being able to get right directly to here, I am fine with that as well. That's a good, but this is an absolutely fine method to use. All right, now we're not finished solving, are we? We need to use that null factor. If you do use this method, you need to make sure you change your factoring job back into this so the marker can see your factoring job. Okay, so I'm using the null factor. This bracket could be equal to 0, or this bracket could be equal to 0. So let's continue here. E to the power of x minus 2 could be 0, or e to the power of x minus 1 could be 0. Finish solving. E to the power of x equals 2 here. E to the power of x equals 1 here. We need to solve for x though, okay? And we know how to do that because we know about logarithms now. All right, so we could ln both sides of the equation. I would choose ln here because we're using the natural base, so therefore use the natural logarithm as well. Or you could rearrange into a log if you wish. I'll do one each way so you can see each of those. On this side, I'll rearrange into a log statement. So log base e of 2 is equal to x, and proper notation for that is just ln 2. So x equals ln 2. All right, and that's a number. If this was a no calculator question, you would leave your answer like this, ln 2. All right, if we choose to log both sides of the equation instead, I'll do that one over here. I'm going to choose ln though, log base e. Ln e to the power of x equals ln 1. Okay, now I'm going to write this out as base e so I can see it better. I like that. Log base e of e to the power of x. Oh, okay. Well, this is going to be equal to x, isn't it? Equals log base e of number 1 can be represented as e to the power of 0. Okay. So this number using our rule. So now I'm thinking about the fact that log base a of a to the power of x is actually equal to x. So if this and this are the same, then the value of this entire expression is just that value. So here we have that situation. So now we have x is equal to 0. Okay, so two answers here. X could be 0 or x could be ln 2.